Hello, in this video I will read and try to comment article published in some peer-reviewed journals, and this is my website actually, so there are articles listed and selected by me, and you can also register to share article. So let's select an easy article, maybe anxiety in patients with schizophrenia, epidemiology and management, or protective role of endocannabinoid signaling in an animal model of haloperidol-induced tardive dyskinesia, or okay, let's select this one. It seems interesting. It's published in we will see that which year it was published. Thanks to my extremely fast internet, there is a lag like 10 seconds. So this protective role of endocannabinoid signaling in an animal model of haloperidol-induced tardive dyskinesia. So as you know, tardive dyskinesia is a movement disorder due to side effect of certain medications, mostly used for schizophrenia treatment, like antipsychotics. Protective role, and so endocannabinoid signaling has some role in an animal model, possibly, according to this article. This is the it seems attractive. Title itself sounds novel, and published in 2021. It's quite a new article, and they are from Brazil. It's not important where are they from, is not really that important though. So which is a pharmacology of biochemistry and behavior journal. So we can only see the abstract part, I guess. So, and haloperidol-induced tardive dyskinesia in rats. So how it is highlighted, I don't get it. So haloperidol can induce tardive dyskinesia in rats, and I think previous studies have shown that. So I'm not sure how to pronounce because I'm not native speaker. Volko's chewing movements occurred only in a subset of animals as reported in clinical studies. Only in a subset of animals. So endocannabinoid hydrolysis inhibitors ameliorated this movement disorder. So it has something to do with treatment of the movements, unwanted, and these effects were prevented by CV1 but not TRPV1 blockade. It seems quite interesting, and let's read the abstract to understand it better. Tardive dyskinesia is a side effect associated with long-term use of certain antipsychotics. And considering the modulatory role of endocannabinoid system upon dopaminergic neurotransmission, so if you are thinking, so antipsychotics is also dopamine related medicine, so that reversing something about antipsychotics. The present study, so that's why I think this is the goal of the study. The present study tested the hypothesis that increasing endocannabinoid levels attenuates haloperidol-induced TD in male, so especially these movements in male visitor rats. So we have to know about the method in detail. The animals received administration of chronic haloperidol followed by those substances, those things, inhibitors before quantification. The underlying mechanisms were evaluated by pretreatments with CB1 receptor antagonist or a TRPV channel blocker. Moreover, CB1 receptor expression was evaluated in the stratum of high VCM animals. As expected, haloperidol-induced VCMs only in a subset of rats. Either PAAH or MAGL inhibition reduced those movements. These effects were prevented by CB1 receptor antagonism, but not by TRPV1 blockage. That's interesting. Remarkably, CB1 receptor expression was increased high in movement in those rats, with a positive correlation between the levels of CB1 expression and the number of movements. In conclusion, increasing endocannabinoid levels results in CB1 receptor mediated protection against haloperidol-induced TD in rats. The increased CB1 receptor expression after chronic haloperidol treatment suggests a counter-regulatory protective mechanism. So that is interesting. So here they test on the protective role of it, so they don't really treat it with it, and that's why. And it's important to use that not only one type of blockage, or using several blockades, and only one of them particularly have an impact on it. So that seems quite brilliant study, and it has a clear suggestions. I'm not sure how much it's original, because I didn't read about the signaling system, and I'm not knowledgeable and expert about it, but it seems quite useful study. And thanks for watching this video. And if you watch all other videos of me, I will be very happy. So have a good day, and wish you luck in your studies.